Hello everyone, I'm Gang Dong. We will talk about the feasibility of solar energy in Australia. We are Group 16 and we have 5 group members. I'm Gang Dong and I will do the introduction. James will talk about the scales, impacts, and the solution to solar system energy system. Philip will talk about the reduction of carbon dioxide emission by using the solar energy. Zhonghui will talk about the feasibility of solar energy in Australia. Yin Yang will do the final conclusion. So this is the current energy structure in Australia. We can see Australia's energy structure heavily relies on coal. So decreasing the coal usage in Australia can clearly decrease the carbon emissions. So we can find an alternative such as solar energy to decrease the carbon emissions. So I will also talk about the Paris Agreement targets and energy crisis in Australia. Initially, the targets were set by 20% on 2000 levels to achieve Paris agreements. However, with a few more years carbon emissions from previous government, Australia have to decrease 43% carbon emissions by 2030 on 2005 levels. So, and Australia currently is experiencing energy crisis due to high demand and prices of the coal in international market. So, solar energy could be an alternative to solve both energy crisis and achieve Paris Agreement in Australia. So, next, James will talk about the land yield of solar energy in Australia.
Solar energy systems operate at two main scales, rooftop solar and utility-scale solar. Rooftop solar is designed to support household to commercial scale energy consumption and requires an accordingly small area for installation. As such, these systems are land use efficient as they utilize space already occupied by urban infrastructure and do not compete with other land uses. Rooftop solar density is incidentally higher along the urbanized eastern seaboard. However, only 2 to 3% of urbanized surface area is typically optimal for photovoltaics due to several environmental criteria needing to be satisfied. Conversely, utility-scale solar, or solar farming, operates to satisfy much higher electricity demand, i.e. greater than 1 megawatt, thus requiring expansive tracts of land farther inland from urban centers. Solar farm construction typically requires land clearing and excavation works, which has been a cause for concern in regional and farming communities such as in Nyngan, New South Wales, based on perceived threats posed by the industry in terms of loss of agricultural land, reduced property values, soil erosion, and wildlife habitat disturbance. In reality, however, the prospective land area needed for solar, even when combined with wind power, is minimal, with the 50 gigawatts required by both technologies to replace coal plants by 2040 being less than 0.02% of Australia's land area, as opposed to the 58% occupied by agriculture. Moreover, viability of solar farming does not strongly coincide with Australia's arable wheat sheep belts. Rather, it increases gradationally towards the tropical northwest, where solar radiation is high and land use intensity is low. Additionally, the land use impacts posed by solar farms can be minimized through strategies such as construction on already degraded land and through the coupling of solar farms with livestock grazing and shade-tolerant horticulture. These so-called agrivoltaic systems enhance land use efficiency by co-locating and minimizing land deficits for up to 3 separate land uses: energy, agriculture, and conservation. They can increase returns by up to 30% and land productivity by 60 to 70% in some cases, with research in Europe conveying that solar farms can not only increase crop productivity, but also support higher biodiversity than arable fields. While these approaches have not been implemented at a large scale in Australia, overall, utility-scale solar has a land use efficiency rating higher than coal, oil and gas, and even renewables such as wind and hydropower, and should therefore be prioritized in a land use context.
All right, so I'll be talking about solar energy in regards to CO2 emissions. So firstly, I'll start by mentioning that despite its ability to be a much healthier and cleaner energy option, there is still general skepticism that exists in regards to solar energy that I found to be quite surprising. So in the scientific literature, there are contrasting thoughts around the viability and effectiveness of solar energy vis-a-vis its ability to reduce carbon emissions, which I found to be quite interesting. So you have studies that have found strongly the positive impacts of solar energy, such as the reduction of carbon emissions as well as its overall reduced carbon footprint. And then conversely, you have studies that have found no significant impact on carbon emissions, and its overall role in carbon reduction, although that may be skewed due to looking at specific parameters such as the concern of solar energy's economic viability due to a costly and complicated installation process. Nevertheless, though, compared to fossil fuels like coal, we can clearly see that solar energy is still a much more viable energy source. As we can see based on this diagram, coal emits roughly 1,000 grams of carbon per kilowatt hour compared to solar, which emits roughly 40 grams of carbon per kilowatt hour. Moreover, the bulk of CO2 emissions in solar energy is in what is known as the upstream process, where carbon emissions are associated with aspects of manufacturing, raw materials extraction, transportation, installation, maintenance, decommissioning, and dismantlement of solar panels. However, you can see that once it's operating and continues to operate, the number goes down precipitously throughout its lifespan. Whereas for coal, for example, over 98% of its emissions occur while it's actually operating. So clearly a less sustainable, more inefficient type of energy. And so overall, solar's carbon footprint, while existing briefly, is eliminated once it begins to be in use. And a roof-mounted grid-connected solar system in Australia, for example, is expected to yield 7 times the energy required to produce it over a 20-year lifespan, more than sufficiently offsetting the initial carbon emissions from the production process, where carbon neutrality is usually achieved between the second and third year of operation for a solar panel. And now Zhang will speak about the feasibility of solar energy in Australia.
Now, I will talk about the feasibility of solar energy in Australia. As a renewable resource, solar energy is highly dependent on external conditions. Sunlight conditions, space allocation, and time constraints affect the feasibility of solar energy in Australia. Overall, Australia has excellent solar resource, and Australia's average solar radiation per square meter is highest of all continents. According to Australia's government's publication, Australia receives an average of 58 million petajoules of solar energy per year, which is 10,000 times the entire energy consumption of Australia. At present, solar energy consumption only about 0.1% of Australia's energy consumption. If the utilization rate of solar energy can be increased, Australia's energy pressure will be greatly reduced. But solar energy has certain limitations in Australia. The first problem is the improper space allocation. The desert area in northwest and central part of Australia has the best condition for solar energy radiation. This makes the solar energy limited in Australia because the most electricity consuming areas in Australia are concentrated in the south corner. The great distance makes it difficult for cities in the southeast to utilize the electricity generated by solar energy in the northwest. At the same time, solar energy also has time limitation because the effective use of solar energy must rely on effective sunlight. Solar energy does not work properly at night. If Australian mainstream grid rely on solar energy, half a day cannot supply the electricity demand. So it has to use alternative energy to take over solar energy at night. Although solar energy has huge development potential in Australia, but limited by current technical condition and the limitation of solar energy resource itself. Currently, solar energy is more like a backup energy source for the mainstream grid in Australia. The scenario for solar energy in Australia are generally off-grid power supplier in regional area or small-scale power supply in household.
In conclusion, the agreement is founded on the most recent scientific findings and establishes a clear and attainable goal for reducing emissions. On the one hand, solar energy is a renewable resource that can be used to generate electricity while emitting no greenhouse gases.
Solar panel can be installed on rooftops, in open areas, or on the ground. Solar farms are large-scale power plants that can typically located in rural areas. They require less land than other types of power plants, such as coal or nuclear. Solar energy is a viable alternative to coal in Australia. On the other hand, it has several limitations, such as improved space allocation, which make it somewhat sparsely limited, and solar energy is 100% efficiency because solar panels are dependent on sunlight. Australia has the sources and capabilities to meet its commitment under the agreement, and it has a strong track record of meeting its international obligations.